Hello everyone, in this video I am going to show you how we can create a decision tree algorithm based machine learning model using Python. So we need to find a data set. So you can refer Kaggle. I found a data set for us that saying PIMA Indians diabetes database, and the dataset consists of several medical predictor variables and one target variable which is outcome. And predictor variables include the number of pregnancies the patient has had, their BMI, insulin level and age, and so on. Here the target variable, let me go ahead and show you the CSV file. You can download that. I will include that in the video description. Here we have outcome, that is the target column. That means with this target column we can identify whether this particular condition is true or false, or absent or present. Okay, otherwise yes or no. Here this have 1 0. 1 means true, that means this person is having diabetics, and this is 0, that means this person is not having diabetics. Okay, so other columns are known as feature columns, but this one, the outcome one, is known as the target column. Okay, let me go ahead and show you another data set. Okay, I go to CSV file. Now here you can see there is another feature column which is K poses, absent, absent, present, absent, kind of true or false are there. Okay, so other columns are age, number, start, and those are the feature columns, but this one is the target column, which is we are analyzing this value and finding whether this particular disorder or something like that is absent or present. Kyphosis is absent or present. So kyphosis will be the feature column and no target column, and other things are the feature columns. Okay, now we are going to build the model for that. For example, we are going to train our model using these feature columns and the target column, and we are going to provide some random values including pregnancies that a particular person has had, and also glucose level, blood pressure, and we are going to provide all of these values and find whether that random person will have the diabetics or not. Okay, so let's get started. I am going to use Google Colab for this. You can use Jupyter Anaconda notebook, or you can use PyCharm or any other environment. So I am going to say Google Colab. I will include this link in the video description. Here we have Colab. So I can press this new notebook. Okay, here how we can upload our CSV file. Firstly, we can press this button like folder icon, then it will be loaded. Till then we can drag our file to here. It is showing me ensure that your files are saved elsewhere. That means the file is in runtime, so then it will be deleted when this runtime is terminated. So you have to keep your file somewhere safe, but you can save the notebook in the Google Drive. I changed the CSV file name from diabetics tree to diabetes.csv, so it will be easier. We can right click it, then click rename file. So the next thing I will do here in the cell, I am going to say import pandas as PD. That means I am going to read our diabetes.csv file into a data frame. I am going to say df, which is standard for data frame. You can use something else for that. I am going to say pd dot read dot csv. This is the function that we are going to use to read a CSV file. Here in the quotations, I am going to pass in my file name diabetes.csv, and then here in the Colab, to execute the code while creating a new cell, we can press shift and enter, then it will be executed, then a new cell will be created like this. And after that we can check our data frame. I will say df.head, that allow us to see the first 5 rows of the CSV file. Okay, we got our first 5 rows: pregnancies, glucose, blood pressures, and these are the feature columns, and outcome is the target column. Okay, so what I can do, check my data frame information. I can use .info function. Here it shows me it have 768 entries, also known as rows, okay, and here it is indicating that there are no null values. That means all of rows have values, but there are no null values. Okay, so the next thing that we can do, we can say df dot shape, that will return us a tuple like this. The first value is the rows count. There are 768 rows, and 9 means columns. Here we are having 9 columns. Okay, so in the next cell I am going to say a new variable called x. I am going to say that equals to df dot drop. That means we are going to extract our target column. Here we have 1 0 1 0, otherwise yes no or absent or present, something like that. I am going to say df dot drop. In the parentheses, as the first argument, we have to pass in the column name that you want to drop. I am going to say the column name as outcome. This is the column name outcome, and the second argument we have to indicate our axis. Axis will be 1. That means 1 represent columns. We are going to remove a column from our database, column known as outcome. But if we say 0 here, it will checking a row starting with outcome, but we want to remove the column called outcome. That why we are saying 1 here as the axis. I am going to store the data frame to the x variable. That means without the outcome column, other columns and rows will be in saved into this x variable. A new data frame will be created. So I am going to say x dot head now and press shift and enter. Here we have all the columns, but we cannot find the outcome column. So the next step is I am going to say a new variable called y. I am going to set that equals to df square brackets, and here I am going to provide the column name which is outcome in the single quotes or double quotes. So this will create a new series, not a data frame, and it will be stored in the y variable. So this is compulsory when we are training our decision tree or any kind of model like a decision tree, and there are random forest algorithm and so on. So here we have our x and y. I am going to check the y now. We will have a series like this. Okay. So what are these? This represent the row. In the first row we had the outcome as 1. In the second row, this one, we had the outcome as 0, and here we are checking the last one here, which is in the third row we had the outcome as 1. Okay. So, we have something like this, and the next step is I am going to say from sklearn dot model underscore selection, and I am going to import the train underscore test underscore split. Okay. I am going to press shift and enter now. The next thing is I am going to create a new variable called xtrain and x underscore test and y underscore train, and the last one y underscore test. Okay. So, what are these? Here this train data will be used to train the machine learning model, and this test data will be used to test our machine learning model. Okay. So, here we have x train and y train. That means x train means our feature columns. Here we have pregnancies, glucose, blood pressure and so on, and y means our outcome column. Okay. So, I am going to set this is equals to train underscore test underscore split. Now, in the parentheses we have to pass in our x, which will be a data frame like this x, and the y, which is the series, this one, and the next argument test size, and that is indicating how many of rows should we take as a percentage in order to test our machine learning model. For example, to define 30%, that means 30% of data will be used to train the machine learning model. For example, if we had 100 rows, it will take 30 rows to test our machine learning model. We can say 0.3 to say 30%. If you want to say something like 50%, you can say 0.5, but I will say 0.3 here. Okay. So, I am going to press shift and enter. Now, let me go ahead and show you the xtrain now. Here we have a data frame like this. If we check xtest now, we have another data frame like this. Let me go ahead and show you shape of everything. I can say dot shape of xtrain. Here I am having 537 rows and also 8 columns. Okay. Now, in the xtest we have 231 rows while having 8 columns, but mainly we had 768 rows, but here we divided those rows into testing and training data frames. Okay. So, the next step is we are going to say from sklearn dot tree, and I am going to import decision tree classifier. For that we can type decision tree classifier. So, this library will do everything for us. We do not have to do such mathematical functions to generate our decision trees, but the only thing we have to do just provide testing and the training data. Let me go ahead and show you. Here I am going to create a new variable called model and set that equals to decision tree classifier. Parentheses and run this. In the next cell I am going to say model, it will be decision tree classifier. I have to run this cell also. Here we can say model dot fit. Inside this I am going to pass in the train data, x train, and the y train. Okay. So I am going to run this. Alright. Now we created our model. The next step is test our model. For that we can say model dot predict and pass in the x test here. Okay. Now I can run this, and after running that we are seeing a array like this. The first element is 0 and the next one is 1. So these are predicted values. Let me go ahead and show you the y test series. If I run this, we are having these rows, the row available in the position of 512, 512, and that outcome was 0. That means that person is not having diabetes, but here it is also 0. The predicted value is also 0. Let me consider this 37 row. Yeah, it is predicted correctly. It is 1, and this row 720. According to the series, that person is not having the diabetes also. Here in the predicted result number 3, that person is not having the diabetes also. Okay, that's how we are using this x test data. So let me go ahead and see the accuracy of this prediction. For that we are going to import a library from sklearn package, import metrics. Okay, run this, and I am going to print the accuracy as metrics dot accuracy underscore score. Here we have to provide y test that we created in the above y test, and the next one will be the prediction result. Here we have to store this model dot predict into a new variable. I am going to say something like y underscore pred equals to model dot predict. Okay, here I will say y underscore pred. Now let's go ahead and run this. Yeah, I had to run this again. Okay, we got the result as 0.7, something like that. Now this will be the model accuracy. How often is the classifier is correct? Alright. So that is it for now. Now how we can pass some values to find whether that person is having the diabetes or not. So I am going to take a look at my df again and check whether what value should I pass in df, and I am going to say print. Here I am going to call to model dot predict. Here how we can pass in values? We should pass in values in a two-dimensional array. Here square brackets, and within square brackets we have to put another square brackets. because here we can provide multiple rows like this. Here for example, this row for this array and this row for this array, like that. Okay, so I'm going to remove this, and instead I'm going to set the pregnancies level as 3 times, and glucose level as I don't know, something like 130. I'm providing just random values, and blood pressure as 78. Yeah, it should be very higher value. I will say something like 50. Yeah, 35 as the next one. Insulin as I don't know, like 60, and BMI as 38.5, and the next feature column value as 0.67. The next one will be the age. The age I'm going to provide as 38. Now if I run this, it is returning me 1. As you saw in the data frame, outcome is available as 1 0. 1 means diabetes is found, and 0 means not having the diabetics. So we can manipulate that. For example, we can use some if statement. If if this is equals to 1, we should take the first value of that, because this is returning something like a list to us. That's why I put the square brackets 0 here, and then if that is true, I'm going to say not having diabetes. In the else statement, yeah, if this is equals to 1, that means diabetes, having diabetes. I'm going to say not having diabetes. Alright, now we are in the last stage. Yeah, it shows having diabetes. Okay, now instead these values, I'm going to use these values like pregnancy is 1. Here the outcome is 0, that's why I am copying that. The next one, glucose level as 85, the blood pressure as 66, the next one will be 29, next one is insulin level as 0, diabetics this thing as, yeah, I got some mistake here, 1 2 3 4, insulin level here, then BMI as something like 26.6, the next one as 0.351, the next one is 31, the age. Now I'm going to run this. It is showing me not having the diabetes. Alright, thank you for watching, and I hope this video helps. If this video helps, please subscribe. Thank you.